Glass is chiefly made by melting silica sand, limestone, soda ash and glass cullets into a fine molten mixture at nearly 1300 degrees Celsius in furnaces. This is the most energy-intensive step in the process of making glass products. Traditionally, the industry here worked with conventional furnaces that used coal as primary fuel. Things started changing in 1996 when the Supreme Court of India directed many units in the area to switch to natural gas. This was meant to protect the famous Taj Mahal from pollution. While this shift resulted in better quality of glass and decreased pollution, the new gas-based furnaces were merely an adaptation of the coal-fired design. The energy consumption continued to remain very high. At this point, the Energy and Resources Institute, or TERI, in association with the Swiss Agency for Development and Cooperation, or SDC, developed a new gas-fired pot furnace for the industry. Pot furnaces are used to melt glass of different colors in the same furnace. Set up first in the year 2000, the design was a great success as it reduced both fuel costs and pollution. The newly designed pot furnace mainly uses the principle of waste heat recovery, a simple method of recovering heat from the flue gases which go waste in a conventional furnace. The furnace is fired centrally by a single burner mounted on top of the furnace crown. A blower supplies the air required for combustion at a fixed pressure. Before the flue gas reaches the chimney, it passes through a heat recovery system called a recuperator. Using this device, the hot flue gases raise the temperature of incoming combustion air substantially, from 40 degrees Celsius to 500 degrees Celsius. Thus, the amount of energy usually required to attain this temperature is saved. As a result of the sound technology, the furnace consumes nearly 35% lesser energy than the conventional gas-fired furnaces. The payback period ranges from 12 months to 24 months, depending upon the furnace capacity and price of natural gas available to the industry. Today, more than 50% of the bangle making units in Firozabad have switched over to the energy-efficient pot furnace.
पहले जब हम बगैर टेरी की सादा जो चला रहे थे भट्टी, उसमें हम 2 टन गैस खा जाते थे पूरी। अब जो हम चला रहे हैं उसमें 15.5 से या 15 से के लगभग चला रहे हैं। तो उस हिसाब से अगर हम गैस की जो कैलकुलेशन रेट करते हैं तो उससे 3 और 3.5 हज़ार के बीच का हिसाब बनता है डेली का, पर डे। इतने अमाउंट का उसमें फ़र्क आ रहा है।
The idea of energy efficiency is slowly catching on in the cluster thanks to the newly designed pot furnace. Entrepreneurs are trying to save energy wherever possible by innovating on existing technologies. For instance, in the Sikai bhattis, where glass is preheated before it is drawn into bangles. One of the entrepreneurs modified the furnace in such a way that the incoming combustion air is preheated using waste heat. Other Sikai bhatti owners were quick to follow. Today, this ingenuity has helped to save up to 10% energy.
सिकाई भट्टी में जो हमारे यहाँ जो टेरी की डिजाइन से रिक्यूपरेटर लगाया गया और जिसके जरिए हवा दी जा रही थी गर्म, वही हमने सोच करके ये पाइप लगाया। तो वही उद्देश्य था कि गैस कम खर्च करेंगे और उसका यूज हमारा ज़्यादा अच्छा निकल के आए तो बेनिफिट रहेगा।
Better designed furnaces have marked the first step towards energy conservation in Firozabad. The real challenge, however, is to make every operation in the cluster more energy efficient. Many auxiliary furnaces are used to make bangles, like the glass preheating, bangle spinning and muffle furnaces. Efforts to make these furnaces more energy efficient can add up to significant energy savings. Large-scale melting of glass for articles like tableware is done in tank furnaces. Most of them are fabricated locally without any standardized design. There is enormous scope to improve the design and efficiency of these furnaces. Simple measures can ensure energy efficiency in the glass industry, like beneficiation of silica sand to remove impurities, use of melting aids to accelerate melting of glass, increased use of glass cullets in raw material mix to reduce energy consumption, optimum sizing of melting furnaces, use of compatible refractory materials and insulations in suitable parts of the furnace, Use of fuel-efficient burners. Following proper preheating schedule for furnaces during startup. Regular flue gas analysis and use of online oxygen analyzer to ensure efficient combustion. Improved design and best operating practices for annealing layers. It is crucial that the knowledge levels of the clusters increase and that energy efficiency becomes a conscious part of their lives so that they can produce high-quality goods at the lowest possible costs. Nearly 180 kilometers from Firozabad is Khurja, another small town that is renowned for its pottery and artistic tradition. Established nearly 600 years ago, today Khurja is a prominent small-scale ceramic cluster that specializes in making crockery, artifacts and electrical goods. Ceramic goods are made by mixing china clay, ball clay, quartz and potash feldspar in ball mills. The slurry is passed through a filter press where it is pressed into cakes. The cakes go through de-airing pug mills to remove air, and the mass obtained is then molded into various articles. After drying and finishing, they are baked at nearly 1200 degrees Celsius in kilns. This is the most energy-intensive step in the process of making ceramic ware. The kilns traditionally used by the industry are the coal-fired downdraft kilns. These are 15 to 25 feet in diameter. Dried articles are placed in saggers and stacked into the kiln manually. It takes nearly 15 days to fire a single batch of products, including loading, firing and unloading time. There is no temperature control and the distribution of heat varies across the kiln. As a result, the baking of the products is not uniform. Often the smoke gets absorbed by the product and leaves black marks. Hence, the rejection rates can be more than 30%. Mr. S.C. Khanna of Naresh Potteries has been manufacturing high-tension and low-tension insulators since 1968. Till 2000, he was using the traditional downdraft kilns. However, when he learnt about energy-efficient tunnel kilns, he was convinced that this was the way forward. He took a bank loan and invested in a tunnel kiln. Fueled by oil and having better temperature control, the tunnel kiln radically changed the way ceramic articles were manufactured in his unit. A typical tunnel kiln has two ends, the loading end and the unloading end. The goods to be baked are stacked on trolleys, which move on rails provided throughout the kiln. The speed of the trolleys inside the kiln is controlled with the help of an electric pusher. The wares move through three zones, namely the preheating, firing and cooling zones. Due to the progressive heat supplied to the wares, they get uniformly baked during their journey in the kiln. A trolley usually takes 24 hours to move from one end of the kiln to the other. Nearly 30 trolleys travel through the kiln in 24 hours. As the tunnel kilns run continuously round the clock and the firing time is lesser compared to downdraft kilns, the productivity of the units have gone up tremendously. In terms of fuel costs, tunnel kilns are 35% more efficient than downdraft kilns. The payback period is around 5 years. Due to temperature control and uniform heating, the quality of wares has greatly improved. With the absence of coal, air pollution has also gone down significantly.
डाउनड्राफ्ट से टनल के में शिफ्ट करने के लिए सबसे बड़ा बेनिफिट तो हमें ये हो गया, हमारी जो 25% से 30% तक रिजेक्शन होती थी वो बिलो 5% आ गई। नेचुरली ये बहुत ही बड़ा एक प्रॉफिट है हमारे लिए। सेकेंडली जो है उसके अंदर हम प्रोडक्शन ज़्यादा नहीं कर सकते थे क्योंकि 15 दिन हमें एक ही फर्नेस पकाने में, भट्टी डाउनड्राफ्ट में पकाने में लग जाते थे। अब ये भट्टी हमारी डे नाइट चल रही है, कंटिन्यूस चल रही है, कंटिन्यूस प्रोडक्शन निकल रहा है। आज आप मटेरियल रखिए, सुबह निकल के शाम तक बाहर आ जाएगा, तो उसमें प्रोडक्शन हमारा कई टाइम्स बढ़ गया, कम से कम 10 टाइम्स इसमें हमारा प्रोडक्शन बढ़ गया।
Today, more than 25% of the units in the cluster have switched to tunnel kilns. Many others are gradually coming forward, realizing that it is profitable for them. However, there is still a lot of scope to improve the energy efficiency of these kilns. Studies conducted by organizations like the Central Glass and Ceramics Research Institute or CGCRI have identified other energy-saving measures for the industry. For instance, replacing saggers with decker plates in kiln trolleys. Saggers with greater surface area absorb a huge quantity of heat themselves. Replacing them with decker plates ensures that more heat is available for the wares. It results in increased production as more material can be stacked per unit volume. This can result in nearly 10% energy savings. Reduction of dead weight in trolleys. Trolleys are constructed with refractory and insulating bricks. The bricks are heavy and the trolley absorbs nearly 55% of the total heat supplied to the kilns. By reducing the weight of the trolleys by using lightweight material like ceramic fibre, there can be nearly 7% savings in energy. Retrofitting the kilns. Since most of the kilns are locally fabricated without any design standards, there is a huge scope to improve the design and efficiency of the kilns. Retrofitting the kilns with appropriate changes like increasing the length of the firing zone and the number of burners in the firing zone can lead to increased fuel efficiency. Using automated roller head jiggers. Traditionally, jigger jolly machines are used to shape various crockery items. Replacing them with roller head jiggers can lead to nearly 10% energy savings and can increase productivity by nearly 5 times. The product quality also increases greatly as there are fewer defects such as warpage and breakage. Testing of raw materials. Systematic testing of raw materials and appropriate raw material size can ensure that the products are of uniform quality and use less energy to fire. The implementation of these measures in certain units has benefited the entrepreneurs. However, such ideas are yet to find widespread adoption in the cluster.
सब चाहते हैं कि हम भी जो अच्छे काम कर रहे हैं उस तरह हम आगे बढ़ें, लेकिन कुछ तो टेक्निकल जो जानकारियां उनको देती है, जो पुराने लोग हैं वो समझ नहीं पाते हैं। दूसरे हैं मेन कमी आ जाती है पूंजी की वजह से ही वो लोग नहीं कर पाते हैं। हाँ, वो जानते हैं लॉन्ग टर्म में पेबैक में हो जाए, लेकिन शुरुआत में लगाने के लिए उनके पास उतना धन नहीं है। दूसरा कमी है कि वो जो पहले से कारखाना चला रहे हैं उसका लेआउट ठीक नहीं है। जैसे जैसे उनके पास साधन हुआ वैसे वैसे मशीनरी बैठा दिए। अब उसे पूरा जब तक हटा करके नए रूप से नहीं सजा जाए तब तक जो है वो सही ढंग से नहीं हो पाएगा। तो इन सब वजह की वजह से वो टेक्नोलॉजी जो है नया टेक्नोलॉजी इम्प्लीमेंट नहीं कर पा रहे हैं।
In the past few years, the Khurja cluster has seen a steady rise in production with special focus on exports. To keep up with the extremely competitive markets, the units here must realize that energy saving will play a vital role in bringing costs down, improving quality and increasing productivity.